Hi guys, how you going? Welcome to our video lesson on acceleration. I hope you're excited. Let's get straight into it. When you think of the word acceleration, you might think of something like this, a car going really fast. Hopefully you guys don't drive like this, but hopefully you earn enough money to own a car like this one. I know I don't. You might think of acceleration with a sprinter, someone running quite fast. I've never seen anyone run with his arms like that, but that is another way that you can think of acceleration. Another way might be something like a roller coaster. I don't know if you guys have been on this one in the Gold Coast before, but it goes ridiculously fast. So you're going to experience that acceleration as soon as you go over that top over there. Oh look, the little Superman's pushing at the back. I didn't actually realize that. Okay, so let's get into the formal stuff. So this is what acceleration actually means. So acceleration has a symbol of the letter A. So whenever you see that lowercase a, that's what it stands for. An explanation of acceleration is the rate of change of velocity over time. There's also a term deceleration. Deceleration is negative acceleration. And think of that as slowing down. So a negative acceleration is deceleration. The equation for acceleration is the change in speed over time. So that symbol means divide, and you can also say it as over. Now, in order to get the change in speed, it's the final speed subtract the initial speed. Acceleration is a vector quantity, which means that we want a magnitude or a size and a direction when we're doing acceleration calculations. At this point, I'd like you to pause the video and record this information in your books. Just finishing off the formal stuff, we've got a few more symbols here. We know that A is acceleration, T is time, that should be a V, and that stands for final speed. V is final speed, U is initial speed, and delta V, so that triangle symbol means delta, that is change in time. So that's a Greek symbol, delta. You can't quite see that, but it says change in speed. So delta V is change in speed. Now, just to clarify again, change in speed, delta V, equals V take U, where V is final speed. So to calculate acceleration, we have an equation. A equals V take U over T. To calculate final speed, another calculation is V equals U plus A times T. Okay, we won't use that too much today, but you're going to use that in the future. Now, all of this stuff here is in your cheat sheet. Okay, all of this stuff is in your cheat sheet, so you don't need to record this. That's what the cheat sheet looks like in case you forgot, that kind of scary looking sheet there. If you lose that, just make sure you ask me for another one. So we're going to go through a practice acceleration question now. So our problem is a car speeds up to 60 kilometers per hour from rest in 5 seconds. Calculate its average acceleration. Express your answer in kilometers per hour per second. And we'll get into what that actually means in a little bit. Now, this is the format that I want you guys to use in order to answer these calculations. It's the same as what we used for the speed equals distance over time calculations. So the acronym that we're going to use is the KEVC. Oops. So K, write down what you know. E, write the equation. V, fill in the values. C, perform the calculation. KEVC, he's a good bloke. Know him, love him, embrace him. So what do we actually know in this question? So we'll do the K part first. So the car speeds up to 60 kilometers per hour. Okay. Now, because I have units here in kilometers per hour, so you've got a distance, kilometers, over the time, hours, I know that that's a speed. Okay. From rest. Now, rest, what are you doing when you're resting? You're sleeping. Hopefully that's not what you're doing when you're watching this video. So the speed at rest is 0. So that's a bit of hidden information there, okay? Now, if it speeds up from rest, that means the initial speed was 0 because it started at rest. So think of your car in a garage. The final speed is 60 kilometers per hour, okay? So we know that. And we know that we have 5 seconds, which is a time, okay? And we want to calculate the average acceleration. So we've got all those units there. Final speed, initial speed, time, acceleration equals question mark, because that's what we're finding out. So now we want to select the equation that we can use where A is at the start and we have the units V, U, and T. And it just so happens that equation is this one here. A equals V take U over T. So we write down our equation. The next part is to fill in the values. So that's just some simple substitution. Substitute the V for 60, etc. Okay. Then you perform the calculation in your calculator, and you're going to get 60 divided by 5, and you get an answer of 12 kilometers per hour per second. So if I could get you to please pause the video again and record that information in your books, just as an example of how to answer these questions. So we have an answer of 12 kilometers per hour per second from the previous question. Now, at the moment, this is probably just numbers and a weird unit. So what does it actually mean? This means that the car's speed is increasing 12 kilometers per hour every second. So every second, the speed's increasing by 12 kilometers per hour. So we have a simple chart here. So we've got time, 0 seconds, 1 second, 2 seconds, 3 seconds, and we have our car coming in. At time 0, that car will not be moving. It'll be stationary. Now, after 1 second of experiencing an acceleration of 12 kilometers per hour per second, you're going to have that car moving at 12 kilometers per hour. And you can think of that on your speedometer in your car. After 2 seconds, that car, after 2 seconds of experiencing an acceleration of 12 kilometers per hour per second, you have to add another 12 kilometers per hour on the speed. So 12 kilometers per hour at 1 second. At 2 seconds, the car would be traveling at 24 kilometers per hour. And after 3 seconds, the car would be traveling at 36 kilometers per hour. And so on and so forth. So you're adding 12 kilometers per hour every time to the speed of that car. So that's basically how it works. And the longer it's experiencing that acceleration, the higher the max speed will be. So now it's your turn. We have another question here. This should have an of there. Sorry, my face is covering it. How embarrassing. I want you guys to please write this down and attempt this problem in your books. So pause the video and have a crack. So now that you've done that problem, I'm going to leave you with a final thought. We have a truck looking like this, and that truck is experiencing an acceleration of negative 25 kilometers per hour per second. I want you guys to write down what you think that means. So what does negative 25 kilometers per hour per second mean in relation to the stopping of this car or truck or whatever it is? Now that car is traveling at a speed of 100 kilometers per hour. So if it's experiencing an acceleration of this, how long would that car take to stop? Record and let me know. Thanks for watching, guys, and I'll see you in class.